All right, welcome everyone. The weekend is close, and so I think we can all feel it, right? The excitement of not having to be at this university anymore. All right. So how many of you are finished for the day after this class? A few? All right. So I'm the gateway to your weekend. That's either a good thing or a bad thing. Hopefully it's a good thing. Let's begin with some announcements. First of all, your next homework assignment is due on Tuesday, February 16th. I've already given you that paper. If you lose it or misplace it, it's also posted on iLearn, so you can always see what the assignment is from that. Next Thursday, a week from today, we're going to have our first quiz, and that's not anything you need to worry about or really even necessarily study for. I just mention it so that you don't, in your mind, say, well, I'm just going to watch the video that day. That's one you definitely need to be here in class for. So if you know how to do the homework assignment, and I don't mean if you just put the marks on the paper, if you actually know it and you can understand it and you sort of have comprehended those concepts, then the quiz will come very easily for you. And in fact, I feel like at this point in the course, everything is very simple and easy, and that may get you into a false sense of security. So just as a warning, eventually it's going to get a little more difficult, and so don't dismiss the course and sort of tune it out, because you need to keep up with these easy principles because they form the foundation for what's going to prepare you to just sail through the hard stuff when it does come. All right? So today we're going to talk about compounding. In our last example in class, we did compounding kind of the hard, unpleasant way, like as a repetitive process. And so we're going to start to look at the more automated ways to do calculations related to compounding. Before we get into that, I also want to introduce a guest that's with us today, Ryan Brown. He's in the back. Everyone can turn around and make him feel awkward. Let's all stare at Ryan Brown for just a moment. He's visiting from the United States, a state called Utah. He's my cousin. So he's here in the UAE on a visit. It's his first time in the Emirates. So I'm trying to show him all the nice places and eat in all the fun places. So yeah, I took him to Karachi Darbar yesterday, which is one of his favorite meals in his life. So we're having a good time with him visiting. So he wanted to learn. He said, what's your favorite class? And I said, for sure it's my 11 o'clock class. It's the cost analysis. They're the best students. It's the most interesting material, so you have to visit this one. So that's why he's in this one, all right? All right. So let's talk about compounding and interest. Simple interest is when the interest itself isn't receiving additional charges. And in the example where we said that if you put an investment in, remember the kerosene example last time? We put in money into an account, and then at the end of the time period, we just calculate the return by a single one-time percentage. So that example we did previous class was an illustration of simple interest. It's where you're only considering the principal, which is the original amount that the bank loaned you. And so for a formula, we can calculate the quantity of the interest, I, by looking at that principal amount, the number of periods, and then the interest rate per period. So let's look at a quantitative example that shows us that. If you are taking a loan of $100,000 for 3 years and the simple interest rate is 10% per year, then all we have to do to find the interest amount is P, which is 100,000, and number of periods, and here are, well, it's not a compounding period, but it's the loan period, the period in which we're calculating the interest, 3 years, and then the interest rate 10% per period. So the interest amount is 30,000, so if that one lump sum comes due at the end of 3 years, we have to give 130,000 back to the bank. Simple interest is very uncommon in the real world. I can't think of very many agencies that are going to loan money where they don't charge interest on the interest. So we talk about simple interest just as a background for you. Far more common is the compounding interest. And in the case of compounding, you have to pay interest on the principal plus all accrued interest. And so accrued is an important word there. And what I mean by accrued is at every instant that the money is compounded, and so if the bank is once per year looking at your account and seeing how much they gave you and how much they owe, that's called the compounding period. And different accounts compound different frequencies. Sometimes there's annual compounding, monthly, there's daily compounding even. So they look at the account and they say, how much did you borrow and how much interest have you accumulated up till now, and then they charge you the new interest amount on all of it. So on the accrued interest and the principal. Accrued interest, it just means that all that you owe up until a certain point is considered. And so let's look at the numbers, because I think the numbers will help you to feel the definition a little bit better. In terms of this formula, it's the principal and all accrued interest times the interest rate. So here's the formula. This looks pretty spooky maybe. It's much simpler sometimes than the formulas make it look like. So the principal amount is what we're going to use to calculate the cumulative interest amount at a certain time. The lowercase t just means at a certain time. So all of the interest periods, j is 1 until the previous interest period. T minus 1 means last year. So let's just think that this is every year. So whatever year we're on, the bank is going to look at all of the interest that is accumulated up until the previous year, and then you multiply the interest rate by the total amount that is accrued. So here is the definition for the amount that's accrued. It's the amount that they originally loaned you and all of the interest that's accumulated up until this point. So let's step through year by year another one of these examples similar to what we did with the in-class exercise last time. So the same $100,000 amount, but this time we're going to look at how much would you owe if it was compound interest instead of the simple interest. What is the repayment after 3 years if it's compounded annually? So in the first year, you only owe them $100,000 because there hasn't been any interest that's accumulated. Let's do a cash flow diagram just to make things simpler. Okay, this is from your perspective. When you receive the $100,000, what direction should I draw the line? Up, because you're getting the money. So here is the $100,000 that you receive at 0, meaning at the beginning of the loan. So here at year 1, this is the end of the first compounding period. And since they're compounding annually, it means that this is the first time they're looking at the fact that you have their money and they want some extra payment for that fact. They want you to pay them for the privilege of holding their money. And so when they do that calculation, they use the formula of the principal, and now here's the interest amount, that there wasn't any previous accrued interest, and so the first year is kind of like simple interest. It's the same amount because there wasn't a previous interest amount. But that's not true at the end of year 2, because at the end of year 2, you owed $110,000 previously, and so this $110,000 is what they're multiplying the interest rate by. And so you can see that although you only owed $10,000 in interest during the first year, now you owe $11,000 in interest because you have to pay them the interest on the original amount that you borrowed, and so that's where the $10,000 is. But this extra $1,000 is now they're charging you interest on the interest from last time, because you didn't pay them that yet. If you had paid them that interest that same first year, then it would have canceled out the interest. But in this example, what we're going to do is we're going to make it a single repayment at the end of the 3 years. And so we're not giving them back anything until one lump sum at the end. Okay, so it goes from $11,000, and then in the third year, we follow the same pattern. You take the previous balance of $121,000, multiply it by the interest rate. So that means now, for that year, it's $12,100, and you add it to the previous amount, and then the total amount due, $133,100. So here's $133,100. So if we had paid simple interest, it's $130,000. Compound interest, $133,100. So why do you think the banks like compound interest? They get more money, of course, right. And the more frequently they compound, then that means they get even more. Because if they compound every year, then that whole first year, it's sort of like you're not paying interest on the interest. But think about, what if they had compounded at the end of every month? If they're doing their calculations at the most frequency, then you're going to have to pay a little bit more interest even. All right, so this difference between the rate that they quote and the rate that you pay is what we're going to differentiate between nominal and effective interest. Nominal interest is when the interest is compounded more than once per year. I just mentioned sometimes the banks will compound monthly. So let's just consider quarterly. Quarterly means every 3 months, 4 times per year, once per quarter. If you had a bank that is charging 16% per year, but it compounds quarterly, then the effective interest rate is going to be greater than that, because the 4% per period is going to earn interest as well. It's not just the principal, but you're paying interest on interest. Now, the effective interest is when you're looking at the actual interest rate earned or charged per time period. And so if you take the annual interest rate of 16% and divide it by 4, because there's 4 quarters in a year, then that would be 4% interest per period. And so effective is when it hasn't compounded yet. Here's a formula that allows us to distinguish between the two. I is going to be our effective annual interest rate, and R is the nominal interest rate per year. And this only applies when they're compounding more often than once per year. So nominal and effective are the same if it's annual compounding, but they're different if it's compounding every quarter, every month, every day. And so I think that examples sometimes make these illustrations the easiest to see. Let's look at, for that 16% that was mentioned on the previous slide, if that's our nominal annual interest, and we want to find out the effective interest rate when it's compounded quarterly. So what we do for that one is just first of all identify the variables. So R is going to be the nominal interest rate per year, 16%, which we'll write as 0.16. If we're compounding quarterly, then that means that M is 4, because there's 4 times per year that the bank is going to check your account and tally up the amount of interest that's owed. Okay, so let's substitute that into the equation for the effective interest rate I. We've got 1 plus R divided by M to the M power minus 1. Okay, so that's 1 plus 0.16 divided by 4 to the 4th power minus 1. All right, and we can see that that's just going to be 1.04 to the 4th power minus 1. And 1.04 to the 4th power, that is 1.16986 minus 1. So that is 0.16986, and if we express that as a percentage, that's 16.986%. So if a bank is charging interest, which nominal or interest, which of those do you think they're going to put on the advertisements? They want people to think it's as little as possible, right? I mean, what sounds less, 16% or almost 17%? And so the interest rate that they're going to advertise is the nominal interest rate, but the effect of compounding brings it even higher. So you have to be a little bit wary of that. Okay, so I've got another in-class exercise that's going to take the majority of our time today. I wanted to give you just one hint before we dive into it. And that is on the first problem, I give you some information. I say the ratio of future amount to present amount, and then I provide a formula. We're going to do a lot of these kind of formulas in problem solving in the future, and I want to help you interpret this first information that's in the parentheses here. So what this means, F divided by P, I%, that means for a certain interest rate, N means for a certain number of years. So we'll have formulas that are formatted this way, and then also tables where they substitute specific numbers into the formulas, and they just give you the values directly, so you don't have to use the equation. But the way to interpret this is f divided by p is 1 plus I to the n. So that if you're solving for f, the future amount, what you do is f is p 1 plus I to the n. Okay? So you'd put in a certain dollar amount for the present value, and then you would be able to solve for what is the unknown future amount. And so what would you do if you have this formula and you're trying to find what is the present value if you know the future amount? You just, algebraically, you'd switch it. So p is f divided by this part of the expression. All right? So here is the in-class exercise paper. The main stuff I'd like you to look at for now is on the front side of the paper. And if you get through that really quick and you check the answers with me, then you can get started on this sort of extra practice on the back, which is interpreting a cash flow diagram, interpreting a problem statement into a cash flow diagram. Yeah? Pardon me? I don't know that it has a name, really. It's not like in fluid mechanics, you know, where you've got Euler's equation and Bernoulli's. This one isn't named. Maybe we should vote on a name for it, you know? The Tiger equation or something. The weight, no. I wish I could keep track of credit for something like that, but it's not mine. All right. There you go. So you like Karachi Darbar, huh? That's a good place, right? You're Pakistani? Yeah, it's tasty. You gonna help him with the calculations? I think you should have to do the calculations there, Ryan.
I've already done it.
Oh, you've got it in your mind? All right. If it's quarterly, then you divide by 4, and then this one would be 10 times 4, because then it would be 40 compounding periods. Exactly. Yep. Yeah.
Per year, quarterly, I divided by 4, but is there something else I need to do?
Yes, then you put it into the formula where you have I effective, you know, R and M, that one.
Okay.
Yeah. Yeah.
We have a problem with interest.
Okay.
What goes on here exactly?
Right. All right. So you're doing it every month. Then it would be this divided by 12.
Okay.
And then that'll solve it. Quarterly means 4 times per year. Yeah.
Can you go back to the formula?
Sure. Yeah, let me pull that up. Okay, let's look at the solution for the first couple of problems, just so that we can all catch up under the same spot where we're working. All right. Start with problem 1. Okay, problem 1, we're using the ratio F to P. We know the present amount is 25,000, and then we can calculate this factor here, 6.6143. So what that means is that the amount you deposit is going to grow by 6.6 times during the period that it's growing. So if you know that it grows by a certain factor, then you just multiply it by the original amount and you find the finishing amount, 165,000 dirhams. Okay? That shows the power of compound interest right there. that you're starting with only 25,000 and you have 165,000 at the end of that time period. If you leave it in for a long time, the interest is earning interest. And that's when you can really get a huge amount accumulating. Any questions on the first one? The second one is likewise relatively simple. We've got 95,000 dirhams that we need to have. That's the future amount in 15 years. And it's 4% per year compounded annually. So I is just 0.04. Same, substituting into the factor, but this time we're solving for the present instead of solving for the future. So that one gives us 52,750 that we have to put in now. Okay, problem 3 is the one that is a little bit tricky. I'll show you the way that I did it, but there's actually an alternate way of doing it as well. So I first looked at plan 1, and plan 1 is the one that it's 7.5% annual interest compounded annually. So if I want to calculate the factor, meaning the ratio between the present amount and the future amount, it's going to be 1 plus I to the power of n. So 1 plus I, where I is 0.075 to the power of 10, because 10 is the number of compounding periods in that period. So 2.06 is the ratio of the future amount to the present amount. So then I can just find out in the future it should be 257,629 if we round off to the nearest dirham. Plan 2 is more complicated because it's compounding monthly. So in 10 years, there's going to be 120 months. 12 months per year times 10 years gives us 120. So I find the interest rate per period. If it's 7.25% per year, then I want to find out how much interest is there per month. So divide the annual interest rate by the number of months, and then this very small interest rate here, 0.0060467, that's the interest rate per period. So that interest rate per period plus 1. So 1 plus I to the n, where n is the number of periods. So I get a slightly different factor. These two factors look pretty close, but they're different. They're not exactly the same. Multiply by the principal, and I get the future amount. So the question asked, how much additional money would you earn by choosing the better? Well, the better plan is the one that gives us the most money, right? So we compare these two. There's plan 1 and plan 2, and it looks like plan 1 gives us more money. So it had a higher interest rate. So if you went to 2 different banks, maybe bank 2 is going to trick you. They're saying, well, we pay less than bank 1, but we compound monthly. And bank 1, they're only compounding annually. So you should come to our bank. Even though we'll only pay 7.25%, monthly compounding will help you. And it would help you, but it wouldn't help you enough to overcome the fact that bank 1 pays the higher interest rate. So you should choose plan 1, even though plan 2 offers the more frequent compounding. Now, if it was the same interest rate, and one is offering annual compounding and one is offering monthly, you should definitely go with the monthly compounding, because in the end that would give you the greater return. The alternate way of solving this is to find the 7.25, like what is the effective interest rate of that? So, and then treat it as though it was plan 1. But for me, I think that calculating the interest rate per period is what we're going to do more often as we move forward. So that's why I show you that form of the solution. Any questions about this third problem? Okay, what about problem 4? You're given the credit card interest rate, 24% per year. And that's not unheard of. There are plenty of credit cards out there that charge 24%. So if it's compounded quarterly, then the 24% nominal is 26% effective. If it's compounding monthly, it's even higher, 26.82. Compounding daily, 27%. So credit cards are another instance where they want to conceal the fees as much as they can legally. Sometimes they have a legal obligation to tell you what the fees are, and what is the effective interest rate, but 24 looks a lot better than 27%. So if they have their choice, they're going to quote the nominal interest rate rather than the effective. Any questions about the fourth problem? Okay, well, I'm going to bring the lights up again so that you can solve this last one, which is translating a seemingly ambiguous word sentence into a cash flow diagram. I've intentionally, it's a little bit vague, but there's nothing that's too vague here. So this kind of problem statement would be fair game for like a quiz, for example. If you had to translate a word problem into a cash flow diagram, this is something that is the level of difficulty that you could expect. Which one? Yeah, the fuel costs are an A, and then this is a F. Because it's in the future. Yeah. All right. So here's how I drew it. Let me show some of the key elements you'd have to have in there for a full credit answer. Okay, so if you want full credit, you need to, number one, label when something is an A or an F or a P. The problem statement never gave us anything in the P. Maybe this is the kind of problem where they would ask, how much should you pay in year 0? But it actually didn't ask that. So I've got nothing drawn on the cash flow diagram for P. So, yeah? If you put a question mark? It didn't actually ask that in the problem statement, but it would be okay if it had, yeah. All right, so we've got the revenue is 247,000 dirhams every year. And so I'm showing they're the same height. That's one key element. And then the other thing is that it would be okay either if you combine this last year into a single arrow and wrote the total amount, or if you have, in my case, I have the annual series. And I like to keep everything separate. So that's why I don't combine it. And I had some people asking, is it okay to subtract the fuel cost from the revenue and just write the net cash flow? And it can be okay, but I think it's better to keep everything separate because sometimes like one element of a cash flow diagram might change, like maybe the fuel costs are a little higher or a little lower, and you want to have the flexibility of changing that one thing without it not affecting everything else. So it's best if you keep each element by itself. Yeah. Yeah, I ran out of room. So you're wondering like why it's so much smaller? Oh, because I always put the annual series on the bottom. Because you want to look at the total amount for year 5. Okay, so the key things for full credit is you have to label the F's, the A's, and it's also good to put the currency if the currency is known. All right, so before I turn you loose, we've still got 2 more minutes. The weekend has begun, right? All right. It's a really good habit to start your assignment early. Don't procrastinate. If you get some of the assignment done over the weekend or even finish it, then you'll feel that much more relaxed through the week, all right? So enjoy the weekend. I'll see you again on Sunday.